Assalamualaikum and hi everyone. Today my team and I will be doing a video presentation for the subject code CHM256. Topic is volumetric analysis, determination of acidity in soft drinks. And this is our team, consists of 5 people, including me, Ahmad Akil Haikal bin Ahmad Azrai. Next, Nur Aida Fazana binti Anwar, Intan Zulaika binti Zulkifli, Nur Husna Humaira binti Muhammad Khairul, and lastly Nur Alif Aiman bin Muhammad Imran.
Volumetric analysis is a quantitative analytical method used to determine the concentration of a solution. It measured the volume of a standard solution required to react completely with the analyte. This technique is widely used because it provides accurate and precise concentration measurements. The second point is acid-base titration. Acid-base titration is one of the most common types of volumetric analysis. It is based on the neutralization reaction between an acid and a base. During the reaction, the acid and base react together to form salt and water until the neutralization is complete. During the titration, the standard solution, also known as the titrant, is added slowly to the analyte. The equivalence point is reached when the acid and base have reacted in the exact stoichiometric ratio. At this stage, the reaction is considered complete. Finally, this method is widely used because it provides accurate, reliable, and reproducible results. It is commonly applied in laboratories to determine the concentration of unknown solutions, especially in food, beverage, pharmaceutical, and environmental analysis.
Hi, my name is Ahmad Akil Haikal, and I'm going to be talking about theory. Theoretically, range of citric acid concentration in soft drinks is 1.76 to 1.9 gram per liter. Next, the function of citric acid in beverage, according to theory, is acidulant, flavor enhancer, preservative, and stabilizing agent, which is by lowering the pH.
The objective of this experiment is to determine the concentration of citric acid in a soft drink using the acid-base titration method. By titrating the soft drink sample with a standard sodium hydroxide solution, we can accurately calculate the amount of citric acid present in the sample.
In this experiment, an acid-base titration method was used to determine the concentration of citric acid into soft drink sample. First, a 0.125 mol sodium hydroxide NaOH solution was prepared by dissolving 0.5 gram of NaOH in distilled water and making up the volume to 100 ml using a volumetric flask. Since NaOH is not primary standard, it was standardized using potassium hydrogen pellet (KHP), which has a known purity and composition. This ensured that the NaOH concentration used for titration was accurate. Next, 75 ml of each soft drink sample was collected and gently heated for about 5 minutes to remove dissolved carbon dioxide. This step was important because carbon dioxide can form carbonic acid, which may interfere with the titration results. After cooling to room temperature, 20 ml of the gaseous soft drink was transferred into a Erlenmeyer flask and 2 or 3 drops of phenolphthalein indicator were added. The standardized NaOH solution was then slowly added from the burette until the solution changed from colorless to a permanent light pink color, indicated in the end point of the titration. The titration was repeated 2 or 3 times for each sample to improve the accuracy and reliability of the results. Finally, the average volume of NaOH used was applied to calculate the molarity and concentration of citric acid in each soft drink sample.
My name is Nur Rahman. Today we talk about procedure. First thing first is preparation of a 0.125 molarity sodium hydroxide. To prepare a sodium hydroxide solution, we need using a given molarity and volume. The formula is mass equals to molarity times molar mass times volume in liters. By using molarity, molar mass and volume in liters that provide, we get 0.5 gram of NaOH. That is, first thing first, we weigh
0.5 gram of NaOH, and then we put the NaOH in the beaker. After that, we add 10 ml distilled water, and then we stir to dissolve the NaOH using the glass rod. After that, we transfer the NaOH solution into the 100 ml volumetric flask. After that, we need to add distilled water until it reach the mark. After that, we shake the volumetric flask upside down. We move on to the next step. The next step is standardization of sodium hydroxide solution. First thing first, what we need to do is we need to measure 0.15 gram of KHP, and then we transfer the 0.15 gram KHP into the aluminium flask. After that, we need to add 10 ml of distilled water, and then add 2 to 3 drops of phenolphthalein. And after that, we take our NaOH solution that we prepare early and put it into the burette. After that, we can do a titration. The titration is finished when the colorless turn into the light pink color, and then we need to repeat the titration 2 to 3 times. In procedure, we have determination of the acidity of soft drink. First, we need to prepare 2 types of soft drink. First is Sprite, and then Mountain Dew. For these 2 soft drink, we need to prepare the exact 75 ml of Sprite and the Mountain Dew, and then we transfer the soft drink into the beaker, and then we need to gently heat the soft drink for 5 minutes to degas the soft drink. After that, we need to let the soft drink cool to room temperature. After that, we transfer the 20 ml degas soft drink into aluminium flask and add 2 to 3 drops of phenolphthalein as the indicator. And then we take our early NaOH solution and transfer it into the burette. And then we can titrate the soft drink until the color turn to the light pink. And then we need to record final and initial burette reading. For this, the titration is repeated for 2 to 3 times. Step 1 to 9 are repeat, but we need to use different soft drinks. That's all for me. Thank you.
Looking at the data from the source, the first phase covers the standardization of the sodium hydroxide solution. To determine the exact concentration of the base, it was titrated against a primary standard of potassium hydrogen phthalate. Across 2 identical trials using 0.15 grams of KHP, the total volume of NaOH consumed was exactly 7.4 ml. Applying the volumetric calculation shown on the right, both trials yielded a highly consistent molarity of 0.099 mol per liter, establishing our baseline concentration. Next, this standardized sodium hydroxide was used to titrate 2 separate soft drink samples to determine their total acidity using a fixed sample volume of 20 ml per trial. For sample 1, the trials consumed 3.7 and 3.8 ml of sodium hydroxide, calculating out to 0.00037 and 0.00038 moles. For sample 2, the volumes were slightly higher at 4.2 and 4.4 ml, yielding 0.00042 and 0.00044 moles of consumed sodium hydroxide. To translate these values into acid concentration, we look at underlying stoichiometry. Citric acid reacts with sodium hydroxide in a 1:3 ratio, as shown by the balance equation. By dividing the moles of sodium hydroxide by 3, the moles of citric acid were isolated. This gives an average calculated molarity of 0.00619 mole for sample 1 and 0.0071 mole for sample 2. Multiplying this by the molar mass of citric acid gives us the final mass concentration in grams per liter. In summary, this comparison table highlights that soft drink 2 consistently exhibits higher acidity across all measured parameters. It contains a greater mole count, a higher average molarity, which is 0.0071 moles, and a final total acid concentration of 1.36 gram per liter compared to sample 1's 1.19 gram per liter. This confirms sample 2 as the more acidic beverage of the 2 evaluated.
In conclusion, the objective of the experiment was successfully achieved by determining the concentration of citric acid in two soft drink samples using acid-base titration. Sample 1 contained 1.15 gram per liter of citric acid, while the sample 2 contained 1.36 gram per liter, indicating that sample 2 was more acidic. However, both concentrations were lower than the theoretical range of 1.76 until 1.90 gram per liter. Overall, this experiment demonstrated that volumetric analysis is an effective and relevant method for determining the acidity of soft drink.